Hey everyone, welcome back to my channel and welcome to the first series of Data Professional Stories. I'm really excited for this series, and today we have Mr. Arpit, and he has 4 years of experience in the data engineering domain. He's an open source contributor, freelancer, and a great mentor. Fortunately, he was in my college and he was senior to me, and he actually introduced me into the data engineering domain. He taught me many good services, frameworks, and other things that is used in the distributed system and distributed computing. Currently, he hold more than awesome salary working as a remote developer, and he actually hates going to the office. So, without wasting much of the time, let's hear from the man himself. Arpit, will you please let us know about yourself?
Thank you for having me, Ankush. So, as Ankur mentioned, that I have 4 years of experience in data engineering domain. So, I have started with interning at a company called Social Corps. There, I handled many service-based projects where we delivered dashboards and data pipelines to different state governments and central government of India. Those projects are mostly around processing some data from different data sources and showing them into a nice view so that high level ministers and officials from the government can see how their efforts are looking like into the ground. So after this, I transitioned into Atlan, the same company but different product there. So there we built platform as a service where people can build the data pipelines themselves, catalog huge amounts of data without having to worry about the infrastructure or uh, rising cost or how to manage that data properly. Okay. There same kind of challenges were there, just that they were in different scale. Some 100 to 200 terabytes of data per customer was a normal thing there. After this, I'm working currently at another startup which is in privacy vertical. The same kind of challenges, but the workflows and the use cases are privacy and security related.
Ha- Arpit, we see that there are lots of confusion with respect to the data engineering and how someone can actually start. So can you please let us know how you have started and how you have started as a data engineer? What are all skills that is needed for this data engineering domain, and how someone can start from one particular things and then become a pro like you?
Yes. So the thing to note here is which background are you coming from? Are you an experienced software developer who wants to transition? Are you a fresh graduate who wants to start in data engineering field? Okay.
Right.
So it will depend on that. Let's take an example of someone who is experienced software engineer and wants to transition to a data engineering field. Okay. So there, the transition could be very easy because if you look at the history of data engineers, they came from backend engineers only. They mastered the distributed systems and domain knowledge of the specific fields. So that's why transition from software engineering could be very easy. What you will need to note there is the existing skills you have as an experienced software engineer will come in very handy. Things like how to design a proper relational schema, how to handle distributed systems, how do you handle consistency across systems. Those skills will be very helpful here.
Right.
Uh, The most important part uh, that you will need to focus on is domain knowledge of the data you're working with. For example, if you're working in a supply chain domain, you should know what kind of data you're getting, what kind of data matters to the stakeholders, and what kind of data will actually add some value to the organization. If you master that, the next part will be just learning the different technologies that exist in this field, such as how do you process a few terabytes of data in a Spark job? How do you store data efficiently? Like, okay, you should always store data in columnar format if it's an analytics use case. Obviously, some exceptions to this rule, but in general, you would like to store it in columnar format. How do you handle late type of data? So all of those things you will have to learn, but those should be easier to learn.
Yeah, right. So you have mentioned about the domain knowledge, right? So domain knowledge, one cannot get the domain knowledge without working in some domain, right? It will take at least 1 or 2, more than 2 years of experience in some particular domain. Let it be healthcare domain, change in supply, e-commerce, or any other things. And you have mentioned about Spark. As far as I can see, that Spark is one of the most asked things in the for the data engineering role. And I see that many companies are actually asking the conceptual questions related to a Spark, like what is the difference between a Spark session and a Spark context? What is the difference between RDD, data frame, and data set? How a Spark is better than the map reduce of Hadoop, and many other conceptual questions. So, what do you think about all these theoretical and conceptual questions? That why people are more focused and obsessed about asking about a Spark questions, the questions related to a Spark, and how much important is to is about learning about this Spark, and how someone can actually learn this technology that is that is Apache Spark.
Yes. So Apache Spark, the technology you're mentioning, it has two different parts. The actual knowledge of Spark is the all of the theoretical practical knowledge that you can get, like what are the steps of optimizing a Spark job, uh, how do you parallelize everything efficiently, how do you read data efficiently, okay? How do you detect inefficiency? All of those things are very Spark focused, okay? uh, what you need to know is whatever you're preparing for Spark, you need to know how to apply it in practical
Right,
knowledge. Otherwise, what you're doing is you're preparing for an interview and you're never going to use that knowledge.
right,
If you have done this practically, the theoretical knowledge should just be uh, preparation for interview. That should be easier for you to get. The other part, which is often overlooked with Spark, is infrastructure of Spark.
mhm,
What comes here is, let's say you are processing 50 terabytes of data in a single job. Just the knowledge of Spark will not be completely helpful there. Obviously, you can completely optimize your Spark job and still it will have a few efficiencies. One of the examples of this is uh, there was a time we were processing a large amount of data, but it was still not as efficient as we wanted to be. What we did there was we looked at the Spark job. There was nothing to optimize there. Now we thought that okay, let's look at the infrastructure part. So we looked at are these disks efficient enough? Okay, the instance type we are using, is it good enough? Like in AWS, you get memory optimized
right. The
ones.
storage
There are
optimized.
yes, yes. So if you're shuffling huge amount of data and it's going by the disk in your Spark job, then it's a good choice to get the fastest disks you can get
Right.
on AWS. Okay. If your job is memory heavy or CPU heavy, so you choose those kind of instances.
Right.
Okay. Another thing to note here is that that 50 terabyte data processing that you're doing, it will take, let's say, a few hundred gigabytes of RAM. How do you provision those clusters efficiently? They want to keep that much of infrastructure always running. So all of these
Mm.
infrastructure related things comes with Spark that someone should target
Right.
for a complete 360 knowledge.
Right. So, what you mean to say that a person should not only prepare only from the interview perspective. He should not only know that what's the difference between this and that, and don't mug up how to optimize the Sparks thing. Try to understand the distributed system as a whole. That will help you a lot in the long run of your career. And once you understand the distributed system, then any computing engines will be very much helpful. And you'll be able to understand what is the upstream, what is the downstream that is involved with the any data pipeline, any big data pipeline. That will be really helpful. And what I have also felt that there are many developers who are very good at the theoretical part, but when it comes to the really optimizing something, they actually don't know how to use the Spark UI itself. They are not able to figure out where the problem is, and they just mug up all those concepts and other things. So it will not help you in a longer run. Obviously you can get one job, but if you wanted to be better at this job, then start understanding the distributed system as whole, and that will help you a lot. Thanks Arpit for bringing this point. One more question, as you have mentioned that we do have multiple API of Apache Spark. Somewhat we do have API of Python, that is PySpark. We also have API for R, and we also have the original in original language itself, that is in Scala itself, that is the Apache Spark. And these ongoing debates that we always looked, and on LinkedIn, on many other Reddit and many other platforms, we see that data engineering with Scala and data engineering with Python. What is your personal preference? Is it Scala or Python? Why that so?
Okay, so my personal preference is neither of those things. My personal preference is SQL for processing data in Spark.
Hmm.
Why I say this is uh, there are a lot of cases where writing code for a data transformation job is lengthy and it's a lot hard to
Hmm.
manage. Okay. On the other hand, SQL uh, is easier in those
Hmm.
cases to manage to write. Okay. One of the benefits you get in both cases, both code and SQL, is query optimization.
Right.
Okay, so we are not sacrificing anything there. Okay, but if I have to, let's say, go into the code, SQL cannot do, let's say, X operation. I personally go with Scala because obviously it's completely typed
Hmm.
language. Okay. You do not get any surprises with Scala because obviously it will catch a lot of errors if you make any, right? Python has some inefficiencies on Spark side, they will run the Python function directly instead of compiling because obviously Python cannot be compiled. So those kind of things I find that Scala is better at. Okay, but obviously you will not be choosing Scala or Python just on this parameter. If your whole team is working with Python
Hmm.
in Spark,
Right.
you do not want to go with Scala because otherwise, what would happen is you will be the only one
Hmm.
using something which nobody else is proficient in, and you will end up creating a one node dependency in on your own.
Right.
So that is something as a uh, team you would not want to do this,
Right.
but obviously if half and half is there, you might want to choose
Right.
Scala.
Means there are many benefits which comes while you are using the functional programming functional aspect, that is the using a Scala instead of Python. But yeah, it will depend upon the team and how team will react to it, and that will be the key of adaptation. Okay, right. So you have worked in on, I think, multiple big data pipeline, and there is lots of confusion when we talk about a data pipeline or big data pipelines. Can you please let us know one basic architecture of big data pipeline that you have used and that you have created, and all those services that you have used, and what were all the challenges and other things. So at least it will be easier for the viewer to understand that what big data pipeline actually looks like.
All right, yes. So, with data pipelines, uh, one of the things that everyone should do is to understand how your output is going to be used. Okay, what is the value behind that output? Why I'm saying this is what happens is you design a bunch of data pipelines without actually getting the domain knowledge about this data. And then, if there is a bug in your pipeline, a lot of the stakeholders will be very unhappy because your pipeline ran, it gave the incorrect data, and now they cannot give the presentation to others. So those kind of things you would not want, because it will be that domain knowledge will help you avoid any surprises in the data.
Right.
Once you get all of that documentation of the data, domain knowledge, how people are going to use this data, what could be the uh, different type of data you will be getting, like if there is a country column, will you be receiving 192 different countries, or will you be receiving just five?
Mhm.
So those kind of things, if you are doing transformation, you should be familiar with.
Mhm.
Once all of this is done, you have the knowledge. Now it's time to design the
Mhm.
pipeline. There are a lot of different architectures in the market. There is ETL, there is ELT. Okay. All of those things are there. Your focus should be to choose the best one that fits your um, use case. Now, let's take an example of both of these things where one is better and other one is not. Let's say you are receiving some data from Google
Mhm.
Ads, okay, and let's say you're receiving some other data from
Mhm.
Postgres. Okay, the use case, let's say, is that you want your Google Ads data to be queryable or be used by marketing
Mhm.
people. Okay, let's say they know the SQL and they can use
Mhm.
it. For you, ELT might be a better solution there, because what you can do is you can simply get the data from Google
Mhm.
Ads, normalize that data, put it into a warehouse so that anyone can use it. Uh, the benefit here will be that, first thing, it will be very fast because warehouses are designed for that. Google Ads data is not all that big. Just in case it is and you're hemorrhaging the cost there, uh, feel free to choose a different option like
Mhm.
data lake. But those kind of use cases could be better with ELT. Okay. Now let's come back to another use case where ETL might be
Mhm.
better. Let's say you are receiving some data that is in JSON format, nested JSON and all. Okay. Uh, Nobody actually knows the structure, but you write the code to figure out the structure. You um, put into a nice format in a tabular format or
Mhm.
something, and then provide people the output. In this case, your raw data is not actually helpful to anyone. ELT will be a bad solution
Mhm.
there, because if you load this data, there is no way anyone will be able to use it
Mhm.
properly. So you might be better off with
Mhm.
ETL there. Okay. So those kind of use cases and situations that you will come up with, and then you can
Mhm.
decide what type of pipeline you want to design. Let's say you go with ETL, ELT, all of them pose some or the other kind of
Mhm.
challenges. Let's take ETL, for example. With ETL, one of the major challenges for you will be to connecting to different data sources. Okay. If you have 50 different data sources in your organization that needs to be connected in order to run the pipeline, you will have the burden of writing 50 different connectors in the extract part of your pipeline. So that might be challenging in some way or the other. Okay. Transformation is something that is a very sorted topic. In today's world, you have Spark, you have Dask, you have 100 different frameworks that can do all of the transformation you want very, very efficiently. Okay. With transformation, your main challenge is going to be what uh, do I transform this
Yeah,
into rather than the
right.
technology itself.
Using the business logic and doing the transformation.
Correct, correct. Declarative transformations is one choice that I've seen many people taking. Uh, there, people say that okay, the advantage is I can define the transformation declaratively, and there is just one code who transform that into an actual
Mhm.
Spark job. Okay, people do SQL as well as transformation. So nobody actually writes code there. They will just provide a .sql file that
Mhm.
run this. Okay. For transformation, there is SQL's successor, not SQL successor, but a framework on top of it is DBT. So that is also another helpful choice there for transformation. So that topic is more or
Right.
less sorted. Coming back to the load part,
That's the most interesting,
it's
right?
more challenge. Yes, exactly. It's the most expensive thing. Okay. First thing you will encounter with load is, do I append data to existing data? Do I replace the
Mhm.
existing data? There are use cases
Yeah.
for both, and cost
Yeah, and there are
definitely
problem
attached
of the
to
both.
both
If
of it.
suppose you actually loaded the wrong data and it's a pain, and how are you actually going to delete it, and how you are actually going to tackle it? That's lots of headache that a data engineer experience on day-to-day basis. So yeah.
Exactly. The wrong data is
Hmm.
one challenge. Duplicate data is one challenge. Let's say you ran the
Hmm.
pipeline twice. You need to have a mechanism there to actually detect that you have actually loaded this data. So either you delete and then append again, or you use some kind of data lake framework in case of you're using a data lake to overwrite the existing partitions. Okay. So some of those strategies need to be in place to tackle the error
Hmm.
cases that you encounter. Even if you load everything correctly, and you can guarantee, there are cases where your data is still
Right.
not correct,
Yeah.
right? So what happens there is, let's say you wrote a business transformation, okay, but the data you got was float, and you treated it
Hmm.
as integer. What will happen is you will lose some information there, and your data is incorrect.
Hmm.
Okay, so there are different new technologies that came in to tackle these kind of
Right.
scenarios. That yes, whatever data you process needs to be what you are expecting.
Right.
Meaning, if you are expecting integer, it needs to come as integer
That
only.
data quality
Otherwise, you
checks is
fail
very much
everything.
needed in any big data pipeline. It's not only about using different services and putting it all together. The data quality check is one of the best things that any big data pipeline has. And to put it or summarize all your point, and those who are not from the data engineering point, I will try to put it in the layman terms. So what you have summarized, that the first thing is about the knowledge about the data, that domain knowledge. Without developing, before developing your big data pipeline, then you have to decide that which way to go. There are multiple ways like ELT. When I say ELT, it means extract, load, and then transform. We have another system where we have ETL, where extract, transform, and load. It depend upon the use case. In some of the use case, you don't want to do the transformations, and you want to load it first. So it will depend upon the your use case, and you will be choosing your best way of doing the big data, designing your big data pipeline. And there are multiple problems which are actually involved while developing the pipeline. There are business logic, logic that is more so, I think more clear right now. People are using Apache Spark and other computing engines to do that. And then you have the problem of loading, where you have to understand that on which file format I have to load it. I have to use, I have to load it into red space or many other things. And there are multiple other problems like append, overwrite, and what to do and what to not to do. That's good. But with moving to the next persons, we do see that people who are actually starting in it, and also the student who are in the college year itself, and they try to get into this data engineering domain, and they try to learn the higher part. I mean, when I say the higher part, they try to understand framework which takes times to understand. Instead of focusing on DSA or the SQL part, they directly go to the cloud and try to understand how EMR work, how Athena work, how Glue work, and other things. So, what's your comment on that? Where should one should invest more on the basic fundamental part, like SQL or basic fundamental of DSA, before putting into the data engineering, and how a basic software engineering actually helps in while coming to the data engineering domain? Will you please comment on that?
Yes. So I'm going to agree with your point here that basic fundamental knowledge of software engineering concepts will be very helpful here. Okay. Because what happens there is, if you go ahead and try to learn a technology like, let's
Yeah.
say, Athena, but you have very less
Hmm.
experience
Hmm.
with SQL,
Right.
you'll not be able to appreciate
Hmm.
something like Athena. If you have never heard of distributed systems, how will you even appreciate something like Athena? Because Athena
Hmm.
came from Presto, and uh, Presto has been the most powerful
Hmm.
query engine that exists here today. So the basic knowledge is very much needed in data engineering, because if you look at the history here, about 5 years ago there used to be no jobs for data
Hmm.
engineer one. So there was a reason there that they didn't exist,
Hmm.
because obviously this kind of job demands that you have extensive knowledge of all of the operations, because obviously how are you going to deploy your data pipeline even if you build it with SQL
Right.
transformations and all of those things. So these kind of things would be very much needed. I recommend that someone needs to master the fundamentals, and not even limit to
Hmm.
DSA or SQL. Go to OS, okay, go to distributed systems. You do not need to master everything perfectly. Like on DSA, you do not need to do lead
Hmm.
code hard questions, but at least some knowledge there will be helpful. OS, I recommend because it tells a lot about the low level details of how these
Hmm.
systems work. Distributed systems is an obvious one. You need to be able to address questions like ensuring consistency, ensuring that you're putting enough slots
Right.
for parallelism. All of these questions you should be able to address if you are
Right.
entering this field. There is another aspect of this uh, which obviously doesn't uh, uh, apply here. There are jobs where you just need to write SQL transformations. So there, if you have complete knowledge of SQL, you can ignore
Hmm.
this advice. The one I recommend here is more for people who are going for platform based data engineering, where you own the
Hmm.
complete thing, and your platform that you are building should be helpful to anyone from data scientist
Right.
to data analyst to marketing
Right.
people to sales
So,
people.
as data engineering is a very new domain to the industry, and people actually get overwhelmed when they try to talk with any data engineer. Then they try to ask, "Can I do data engineering? Can I switch to data engineering?" And some data engineering will advise that, "Yeah, I learn this SQL, DSA, then learn Apache Spark, Hadoop. In Hadoop, you have to learn Scoop, Pig, and there are many other things." And people actually get overwhelmed. So base thing is that you understand the concept, you understand the basic fundamental, you understand SQL part, you understand basic of DSA part, and then you try to understand the basic distributed systems. And there are multiple jobs inside the data engineering. There are some data engineer who actually writes only the business transformation using a Apache Spark SQL code, or there are the platform engineer who take cares about the scheduling and the CI/CD pipelines, and they also take care about the business transformations thing. So there are multiple things inside the data engineering domain, and one need to clear their basic concept, and they can really come into this domain. So that was the pretty extensive discussion. Let's move to our Blitz round. Here we will be trying to have some fun, and we will try to understand what's your personal choice. And we will be asking question. It will be like MCQ question. You have to choose one. So shall we proceed? Okay.
Yes,
So the first question is Python or Scala. The second
Scala.
question is drag and drop or write your own SQL query.
I should expand here because this question you will have to narrow down by a lot
Mm-hmm,
of conditions. Drag and drop and SQL both are very much good
mm-hmm,
in their own place. Okay. Something like join, if someone's use case is just join, they should be able to do this with a drag and drop because I do not want to write
mm-hmm,
code for a join where I have
mm-hmm.
500, 600
Okay, for
columns,
this bleach down, we don't need
right?
explanation. We can just proceed for the next person. So for Looker, Tableau, or Power BI,
Tableau,
commercial or open source, obviously.
open source,
Work from home or office, cool.
work from
AWS,
home,
GCP, or Azure, in-premise
Azure,
cluster or cloud, data
cloud,
warehouse
obviously.
or data lake.
That's a tough question, very tough question.
Cool.
I'll go with data
Manual
lakes,
configuration or auto default configurations come with any compute engine like a Spark.
automatic,
Startup or MNC. That's good.
startup.
So we have completed our round. So and we are also not having that much of time. So in the last, what is the one of the technology that you see, the new upcoming technology that can become the face of data engineering? Like nowadays, just many people say it's Apache Spark. You understand Apache Spark, you are good to go with the data engineering. Any new technology that you vouch for, or any new things that you do and do consider that it can become a great in the coming recent year, or will the Apache Spark will continue ruling the market?
So, the face of data engineering, I will not say it
Mm-hmm,
will just be Spark. Okay. It will be combination of two to three tech. Okay. Spark has been there for a long time, so it's pretty well known. The thing that is upcoming or has been there for like 3, 4 years now only is data lakes. Okay. There have been data lakes with Hadoop, so it's been there since last 20 years, but the management on
mm-hmm,
top of those lakes has been very uh, manual or
mm-hmm,
very cumbersome. The things like Delta Lake
mm-hmm,
or Apache Hudi uh, comes to rescue for
mm-hmm,
those management tasks. For example, the append and replace
mm-hmm,
use case that we mentioned, okay, managing the partitioning, okay, how do you overwrite
mm-hmm,
some pieces of data? So all of this is available in
Mm.
Delta Lake or Hudi both, and they work really really well with the Apache Spark. So combination with this of these technologies with the Spark would be the next thing, or already the thing that is
Yeah,
very
nice,
popular.
nice. So that's the end of our sessions. I'm really thankful for Arpit for your time and for making aware about all those things and making aware about all those new technology and what you really experience with the data engineering things. And I think this will be also helpful to someone who are actually starting into the data engineering domain, and they will be in the right track and they will not focus on completing one course or something like that. Instead, they will focus on trying to learn the distributed system as a whole. If they are also taking any course, not a problem, but they should understand the distributed system as a whole, and they should not mug up the things. So yeah, I'm really thankful for the things. Let's hope to meet in the for the upcoming sessions, and let's try to understand that how. Let's go more deeper into the data engineering domain. Thank you, Arpit. Thank you for your time. Thank you.
Thank you for having me.